Now, the last problem was sigma. Array, what is this? Brother, zoom kedate. I have opened a new one. Okay, sigma k goes from 1 to 10 sine 2 pi by 11 times k. Okay, so if you assume this to be unit circle and you are making 11 parts of 2 pi, so first here, and then you will have 2 pi by 11, there will be equal 11 parts. So there will be someone here, and 11, so 1 is gone, 5 here. So 1, 2, little more above.
सर
4, 4, 9. बोला.
सर हा थर्ड प्रॉब्लेम आहे सर, फोर्थ
तर सर
प्रॉब्लेम
तुम्ही
मध्ये
अजून एक
डिफिकल्टी
दिले
होती.
होते त्याच्यानंतर
So you want third problem or fourth problem?
फोर्थ.
Fourth. Okay. So third is easy. What was the answer? Third?
Yes.
0 येतं आन्सर.
0. Okay. So let us discuss fourth problem. Sigma k equals 1 to 6 sine 2 pi by 13 times k. Okay. Now, okay. So let me make a diagram again. Now, I am going to just explain it to you for both ways, geometric and algebraic, both ways. Therefore, bear with me. Suppose I have a circle. Good. And there are 13 parts of 2 pi. So there are, first one is over here, and you need to have 6 more here and 6 more here. 6 in this place, however, you are supposed to be equidistant. So let me try my luck. 1, 2, 3, 4, 5, 6. And then their reflections in x-axis will be sitting here. Why? Because they are present in conjugates. They are not independent. Every time conjugates are also present. So this is your 2 pi by 13k, sorry, 1. This is 4 pi (13). This is 6 pi by 13. What are we supposed to find out? We are supposed to find out 2 pi by 13, 4 pi by 13 plus 6 pi by 13 plus up to 6, 8, 10 and 12. This is 12 pi by 13. Okay. So now if you add all these roots along with this fellow 1 comma 0, this is, we are considering z raised to 13 minus 1 is equal to 0, and we know sigma 1 is equal to 0. So summation of all of them is 0. So we already know that sigma k goes from maybe 0 to 13, 0 to 1 to 13 or maybe 1 to 13. Sine 2 pi by 13 times k is equal to 0. This is what we know. Out of which, if we remove this 13th one, because it is 26 pi by 13, which is sine 2 pi, and sine 2 pi is going to be 0, therefore it will not have any addition in the summation. Therefore, we can actually ignore this 13 and make it, then it is symmetric. Okay, so what we are talking about, summation of this and their reflections is equal to 0. Okay, as far as complex root is concerned, sigma 1 is equal to 0. That means sigma cos 2 pi k by 13 plus I sine 2 pi k by 13. K goes from 1 to 13, that is sigma 1 I am writing. This is what is equal to 0. Summation of all the roots is 0. Out of which, now this you can split this. You can say that sigma k goes from 1 to 13 cos 2 pi by 2 pi k by 13 is equal to 0, and sigma k is equal to 1 to 13 sine 2 pi k by 13 is equal to 0. Real part is 0 and imaginary part summation is also. Now, as far as real part was concerned, this 13th root was contributing 1, and therefore, if we take that 13th root to the RHS, then we used to get minus 1 here summation. I think that problem, something similar problem was already there in terms of summation of cost. But we are not now discussing this problem, we are discussing this problem. And therefore, if you look at the 13th root, which is this, or 0th root, which is this, has sign value 0, therefore I can conveniently ignore this 13 and make it 12. And then if these are 12 guys and they are symmetrically placed, see now cos ratio of both these quantities will be same, both these roots will be same, and their sign quantities will be oppositely signed, and therefore we call them conjugates of each other. So this is first root, this is 12th root, they are conjugates of each other. Second, 11th conjugate of each other, therefore 6th and 7th conjugate of each other. So all of them, all these 12 guys add up to 0, and these are actually conjugates of these, right? And therefore sine, I mean imaginary summation of imaginary part of these 6 roots is going to be numerically exactly equal, but in opposite in sign. Summation of these many, summation of sine imaginary part of these many roots, that is what need to be understood. Therefore this plus sigma k goes from 7 to 12 sine 2 pi by 13 k is equal to 0, and these two quantities are equal in magnitude but opposite in sign. Why? Because all these 6 guys are negative sign ratios. Y coordinates are negative, right? And they are exactly same spaced here. Therefore, this quantity is exactly equal to this, but in opposite inside sign. Therefore, they add up to 0. Therefore, this quantity is equal to this quantity. This quantity is equal to sine of kind of a final answer. Therefore, So this particular answer, let me think, let me switch off the and start the discussion. So as far as this problem is concerned, we will not get good numerical answer because those are bad angles and they are not friendly angles. Their sign ratios will be positive. I mean 1 to 6, all these sign ratios will be positive and they will add up to some positive number. This guy is going to be exactly same but negatively signed, therefore they add up to 0. Up to this it is correct. So now let us use trigonometry to add them, find out what is their sum, because these angles are in arithmetic progression. So when we have summation of sine, what is the formula? Sine first term plus last term by 2 sine d by 2 upon sine d by 2. Okay. Now, if we are feeling so bad about solving this using trigonometry, what we will do is we will develop this formula also using complex numbers, so that we will not feel very bad that we have solved this problem using trigonometry and we have not solved it using complex numbers. We will derive this formula for summation of angles in arithmetic progression, sine ratio as well as cos ratio. Using complex numbers we will derive, so we are free to use it. Presently we were trying to exploit the symmetry of nth root of unity, but not working and it is not giving us the good answer. All earlier 3 problems it was giving us good answer, and therefore now we do not have any chance but to use summation formula. Is this formula correct for sine? Can you confirm that is this
Yes.
for sine summation?
Yes, sir.
Yes. So now can you tell me the first term is sine of 2 pi by 13. That is our first term. What is the sixth term? Plus 12 pi by 13 whole divided by 2. Sine n. How many terms? 6. What is the common ratio? Common difference? 2 pi by 13. Is that correct? अरे बरोबर चाललंय का?
हो सर इंटू
Divided by sine 2
Sir,
pi by
sin n d upon 2.
n d by
6 into 2 pi.
बरोबर येता?
हा सर आता बरोबर
By
खाली पण हाफ
2. Therefore, this comes out to be equal to how much is this? 14 upon 26. So 12 by sine 12 pi by 13. How much is this?
7 pi by 13.
7
7 pi
7 pi.
Sorry. 7 pi by 13. Sine, this is 6 pi by 13. बरोबर? Upon sine pi by 30. And I don't think that this can be further reduced.
सर करू शकतो.
तर करू
करू
शकतो.
शकतो? बरं सांगा कसं करायचं? साइन वापरायचा?
सर साइन 7 pi by 13 म्हणजे साइन 6
तर
pi by
आपण
13.
साइन पाय बाय 13 साइन 12 पाय बाय 13 लिहू शकतो.
It's same. Sin pi by 13.
तर साइन पाय बाय 13 इक्वल्स टू साइन 12 पाय बाय 13.
आणि सर साइन 6 pi by 13 आणि साइन 7 pi by 13 पण
आणि मग
इक्वल आहे.
हो
साइन स्क्वेअर 6 pi by 13 करायचं.
Into 2 sin
येस
3 pi by 13 आणि नाही ह्याला हाफ करायचं ना?
डिनॉमिनेटर
डिनॉमिनेटरला
सर
Yes.
डिनॉमिनेटरला
करतो समजलं. थांबा. आणि मग cos 6 pi by 13 7 आणि 6 13 is sin cos 6 pi by 13
सर न्यूमरेटरचा जो साइन 7 पाय बाय 13 आहे तो साइन पाय मायनस 6 पाय बाय 13 आहे म्हणजे साइन 6 पाय बाय
साइन 6 पाय बाय 13.
म्हणजे tan 6 pi by 13 उत्तर येतं.
अपॉन 2.
सर tan 6 pi by 13/2. सर पण मागच्या वेळेस तुम्ही मला चुकीचं सांगितलेलं.
हो, मग माझी चूक झाली.
हो सर.
बरोबर आहे आता तुझं. कारण माझ्याकडे ना इथे उत्तर 0 लिहिलेलं आहे. 0 कधी क्रॉस चेक नाही केलं पण माझ्याकडे 0 लिहिलेलं आहे समाव. सो दॅट इज अ मिस्टेक. I will correct that mistake now. Okay, so the final answer is half tan 6 pi by 13. Okay, okay, good. So now let us continue. Why should I pause? The idea now is to find sigma sin AI. I goes from 1 to n, and sigma I goes from 1 to n cos AI, where AI is an AP. Okay, using complex numbers. Okay, using complex numbers, we are supposed to find out summation of sine ratios of angles in arithmetic progression and cos ratio of angles in arithmetic progression. I give you 10 minutes. Okay, we begin with this. Zi is equal to cos AI plus I sin AI. That is 1 comma AI is a polar representation of this complex number, correct? Now, therefore, if what we are trying to do is basically we are trying to add cos of angles which are in arithmetic progression and sine of angles in arithmetic progression. That means we are suppose considering z1 plus z2 plus z3 plus dot 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 plus zn. Whatever this z complex number that we will create by adding all these people, it will again look like real part plus imaginary part. C plus IS, this capital Z will look like C plus IS, and then this C is going to be our answer of summation of cos, and S is going to be the answer of our summation of sine. So in one go we will get both the answers, right? So let us try to understand this. This is Z1. Z1, let the first term be A1. So if first term is A1, then this is 1 comma A1. That is our Z1. What is Z2? 1 comma A2. But angles are in arithmetic progression. Therefore it is 1 comma A1 plus D, where D is common difference. Is that right? So Z2 is 1 comma A1 plus D, which is equal to 1 comma A1 into 1 comma D, because argument get added, magnitudes get multiplied. Z3 is equal to 1 comma A plus 2D, which is equal to 1 comma a1 into 1 comma 2d. However, we can write this as 1 comma a1 into 1 comma d square, because argument the coefficient goes to the power, this multiplied by this is this, first term remains same, dot 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 zn is equal to 1 plus a plus n minus 1 times d, that is your polar representation, which is equal to, you can very easily say 1 comma a1 into 1 comma d raised to n minus 1. समझ लें. And maybe what we can say here is, we can write this z1 as 1 comma a1 into 1 comma d raised to 0. This can be written as 1 comma a1 into 1 comma d raised to 1 and dot dot dot. So totally how many terms are there? Total n terms. And we are talking of summation of these n terms, which is summation of this vertically, which is your geometric progression, and therefore geometric progression. Therefore first term 1 comma a1 into r raised to n minus 1. What is r? 1 comma d raised to n. How many terms? N. Minus 1 divided by 1 r minus 1. This is what is our z. Check whether you have understood up to this point. सांगा समजले का इथपर्यंत? अजून काहीच झालेलं नाही. We have just said that
Yes.
summation is there, it can be represented like this, where a1 is your first term, d is your common difference, total number of terms are n. So up to this point everybody is clear. Now there is a fun in geometry, fun in algebra of dealing with this quantity. So let me adjust now. So what we are doing is z is equal to 1 comma a1, now 1 comma d raised to n, 1 comma d raised to n minus 1 upon 1 comma d minus 1. ठीक है?
Sir,
Yes.
sir, can you please explain how we got 1 comma d raised to n minus 1 upon 1 comma d minus 1?
This one?
Yes, sir.
A, AR, AR square, AR cube, dot dot dot, AR raised to n minus 1. These are the, this is the geometric progression and summation of all.
Yes, sir, I understood.
Yes, AR raised to n minus 1 upon R minus 1. That is the formula which we have used. Okay, so now look at the algebra is equal to 1 comma a1. Now this part I am going to write it as 1 comma d by 2 raised to 2n minus 1 divided by 1 comma d by 2 raised to 2 minus 1, which is equal to 1 comma a1. Now we take out 1 comma d by 2 common. 1 comma d by 2 raised to n minus 1 comma d by 2 raised to minus n upon 1, sorry, okay, this is correct, into 1 comma d by 2 raised to n. Here also 1 comma d by 2 raised to 1 minus 1 comma d by 2 raised to minus 1. So you have taken out 1 comma d by 2 common. 1 comma d by 2. बघा इथे समजते का इथपर्यंत? Yes or no?
Yes.
Maybe I can come back.
Yes.
This is 1 comma a1 into 1 comma d by 2 raised to n upon 1 comma d by 2. So these are this part. Now let us look at this. What is this? This is 1 comma d by 2 minus 1 comma d by 2 raised to n bar. Because this is 1 upon this z plus z minus 1 upon z, and if mod z is equal to 1, then 1 upon z is equal to z bar, z minus z bar. Do you realize this? This is what I am using here. This is raised to minus n, that means it is 1 upon this, and 1 upon this where magnitude is 1, it is conjugate. So I written it as conjugate. Similarly, in the denominator, we have 1 comma d by 2 raised to 1 minus 1 comma d by 2 conjugate. And now z minus z conjugate, z is x plus iy minus its conjugate, that is x minus minus plus iy is equal to r2 times I times y. So this is 2 times I times imaginary part. Okay. So this is equal to 1 comma a1 1 comma d by 2 raised to n divided by 1 comma d by 2 into, what is this? Imaginary part of this complex number multiplied by 2i. 2i, what is imaginary part of this complex number? Sin nd by 2. Do you realize the imaginary part of this complex number is sin nd by 2? And what is the denominator? 2i sin d by 2. That is this part. Okay, now let us deal with this. What is this fellow? Is equal to 1 upon d by 2 raised to n upon 1 upon d by 2. That means it is 1 comma d by 2 raised to n minus 1. That is 1 comma a1 into 1 comma d by 2 raised to n minus 1, which we can directly write as n minus 1 times d by 2 into this thing, sin nd by 2 upon sin d by 2. Okay. Now, what is this fellow? This fellow is equal to multiplication. So 1 argument gets added, which is a1 plus n minus 1 times d by 2. This is the argument multiplied by same quantity. But if I clear the denominator, I get 1 comma 2a1 plus n minus 1 times d upon 2. Same. Oh, 2a1 plus n minus 1 times d, which is 1 comma. Is this first term plus last term by 2? Mulanno?
Oh.
First term plus last
Yes,
term
sir.
by 2? Yes or no?
Oh, sir.
Yes, sir.
So what is this complex number? This is आता इथे कसं लिहूया direct? Now we are supposed to separate Okay, so this is 1 comma this argument. So now if we write it in terms of cos theta plus I sin theta, then what we will get is, let us write it in that form, cos first term plus last term by 2 plus I times sin first term plus last term by 2 whole bracket outside sin nd by 2 upon sin d by 2. Okay, this is our z, and therefore what is capital C? Cos first term plus last term by 2 sin nd by 2 upon sin d by 2 plus I times cos first term plus last term by 2 sin nd by 2, sorry, it's a sin by divided by sin d by 2. Therefore, this is C plus IS 2. Okay. Now, there will be some steps which are difficult to understand. If you point it out, I can explain it to you again. If you understand on your own, nothing like it. लिहून घ्या. Now, from here to here, this term is exactly same as it is. This term is as it is. This term is also as it is. Now, this term, suppose I consider z is equal to 1 comma d by 2 raised to n. What is its representation? This is going to be equal to cos nd by 2 plus I sin nd by 2. Correct? What is its conjugate? This and this, these are two conjugates of each other. So its conjugate is going to be cos nd by 2 minus I sin nd by 2. Right? So this is z and this is z bar, which is 1 comma d by 2 raised to minus n, actually raised to minus n, which is n bar. Okay, so now if I add z minus z bar, not add, subtract z minus z bar, then I get this cos gets cancelled and you get 2I sin nd by 2. That is what I have written in the numerator. Similar thing in the denominator. And then 2I gets cancelled and you end up getting only nd by sin nd by 2 upon sin d by 2. Okay.
Okay, sir. Thank you.
First, second, third. Okay. Now third step in blue is like this. Z raised to 2n minus 1 upon z square minus 1, which is equal to z raised to n inside bracket z raised to n minus z raised to minus n divided by z inside bracket z minus z raised to minus 1. Now if we multiply these two, we get z raised to 2n. If we multiply these two, we get 1. If we multiply these two, we get z raised to 2. If we multiply these two, we get 1. So this is what, this is the step. This is the step in this entire proof. And see, nobody will be able to do it independently just like this unless you know the final result and you see that nd by 2 and d by 2 must come out as common. That is the origin from where you realize that we have to take out nd by 2 and d by 2 common. That is the motivation of writing this ratio in this form. And it is not easy to realize that we should write it in this form so that we get out of the trap and we get the final answer. It is not easy it is not easy this way. I think it is easy this way. If somebody has done it this way, then it is a genius. I mean, if you can see that once this is getting factorized like this, you will eventually get this. It's very difficult to imagine. But of course, there are people who imagine like that and they do. But now, whenever you come across this kind of situation in future, you will definitely get a hint that, oh, we have done something like this in this summation formula of cos and sine, therefore let us try that trick. If you are stuck, if you are not able to go ahead with the problem by any other tools that you have, I am sure you will realize that this is the trick that we have used in this formula, and maybe you will be able to solve that problem using this trick. This is a trick which gives us this final result. But then everybody is well behaved. I mean, whether it is a trigonometry, whether it is a complex number. I mean, eventually we get first term plus last term by 2. This is also amazing. You get it? Okay, next problem is absolutely simple when it comes to trigonometry. But now, because we are learning complex numbers and we are learning how to use different tricks to solve complex number, to solve trigonometric problem using complex number, this is next problem in that series. So next problem, falling short of colors. Bright color, orange. Okay, P is equal to, product P is equal to cos 20 degree, cos 40 degree, cos 80 degree. Is equal to. Fine. Okay, I give you 5-7 minutes to try it. I mean, in couple of minutes you will get it using trigonometry, but I want you to try using complex numbers. If you want to solve this problem using complex number, you need to know the trick. Okay. Now let Z is equal to cos 20 degree I sin 20 degree. Suppose we consider Z like this, then can you tell me what is Z raised to n? Z raised to 9.
Cos 180 plus I sin.
-1.
Z raised
Minus 1.
to minus 1. So this is the, maybe we can say this is first root, first complex root of first complex 9th root of -1. Okay, that is how it will look like. So if we take 9th power of Z, we get cos 180 plus I sin 180. I sin 180, sin 180 is 0, therefore this disappears. Cos 180 is -1. This is what it is. Therefore, Z square is equal to cos 40 plus I sin 40 degree. Okay. Now here I would like to go with some additional algebra. We are having this fellow cos 20 is our first term. So now let us understand these steps. 1 plus Z raised to 2. is equal to 1 plus cos 40 plus I sin 40. 1 plus cos 40 is 2 cos square 20 plus 2 I sin 20 cos 20, which is equal to 2 cos 20 inside bracket cos 20 plus sin 20. Hello. तुम्ही जेव्हा जेव्हा फोन करता तेव्हा जेव्हा माझं लेक्चर चालू असतं आता ऍक्च्युली उचलला कारण मागे दोनदा पण बघितला. बोला ना पटकन. हो. नाही तसं आम्ही कोणालाच सांगत नाहीये किती मार्कांची परीक्षा असेल, किती प्रश्न असतील वगैरे सांगत नाहीये. ते ऑन द स्पॉटच कळणार मुलाला. 50%. हो हो हो. थँक्यू. Cos 20 is equal to z square plus 1 upon 2z. Okay, by these calculations. Similarly, can we prove cos 40 is equal to z raised to 4 plus 1 upon 2 times z square? You write down these steps to get this result. Then cos 80 is equal to z raised to 8 plus 1 upon 2 into z raised to 4. Write down these steps to get this result. Once you are done with them, we will proceed. Have you got these 3 terms?
Yes.
All of you have got those 3 terms? Very good. So let us move. So what is our product P which is given to us? P is equal to cos 20 z square plus 1 upon 2z into z raised to 4 plus 1 upon 2z square into z raised to 8 plus 1 upon 2z raised to 4. Now here you can observe that in the denominator you have 1 upon 8 into z raised to 7. And now you have z raised to. So these 3 numerators are now such that if they get support of a negative sign in between, they will all 3 will collapse. Therefore, let us multiply and divide by 1 upon z square minus 1. And you require 2 upon 2z square minus 1. Okay, so multiply and divide. So if you combine these two, you get z raised to 4 minus 1. Again, if you multiply, if you supply, I mean, we should supply 8 upon 8, no? Something like that. Two this into this is z raised to 4 minus 1.
सर
So
2
why
नाही
do I require 2 unnecessarily?
Sir, two
सर ते
one
साइन
more
सारखं झालं.
साइन सारखं झालं. कारणच नाहीये. Okay. So 2 is not required. So this into this is this into this is this. Therefore, eventually what you have in the numerator is 1 upon 8 into z raised to 7 into z square minus 1 upon in the numerator z raised to 16 minus 1 इथपर्यंत
One.
कुठली सगळ्यांची गाडी z raised to 16 minus 1. Now you know z raised to 9 is equal to minus 1. So if z raised to 9 is equal to minus 1 here, then what is remaining? Z raised to 7. Z raised to 9 into z raised to 7 is equal to z raised to 16 minus 1 upon z raised to, I mean this is z8 into z raised to 9 minus z raised to 7. That is what is your denominator. So this is minus 1. So it is minus z raised to 7 plus 1 divided by this is minus, बरोबर चाललंय?
हो सर आता मग ते
हो सर.
This is minus 1, so minus z raised to 7 minus 1 हे correct आहे. आणि इथे काय होणार? This is also minus 1. So this is also 8 into minus z raised to 7 minus 1, which is equal to 1 upon 8. Okay, so that is the trick. The trick is to express cos of angle in terms of z. In terms of z, and without involving any I. So cos 20 z square plus 1 by 2z is a nice identity because we do not have I there and it is expressed in terms of z. Therefore, you get into a rational expression of z, and if you keep simplifying it, you will get the final result. This is wonderful. I am taking these problems for the first time in the class. So shall I give you the next?
Sir, please explain the last step.
This one from year to year.
Z raised to 9 into z raised to 7.
Z raised to 9 into z raised to 7 is z raised to 16, and z raised to 9 is minus 1. So this is numerator is z raised minus z raised to 7 minus 1. Denominator z raised to 9 minus z raised to 7. Z raised to 9 is minus 1. Therefore, z raised to 7 minus z1 minus z raised to 7 minus 1. That is the denominator. And you end up getting numerator and denominator exactly same. Therefore, the answer is 1 by 8.
Yes, sir. Thank you, sir.
Next problem. Now, let us do this. Cos square 10 plus cos square 50 plus cos square 70 is equal to 3 by 2. Prove that. These are degrees. Now, similar lines, basically let z is equal to therefore we get cos 10 as z square plus 1 upon 2z, cos 50 is equal to z raised to 10 plus 1 upon 2 z raised to 5, and cos 70 z raised to 14 plus 1 upon 2 z raised to 7. Is that right? So to prove that z square plus 1 bracket square into z raised to 10 plus 1 bracket square into z raised to 14 plus 1 bracket square upon 8 7 and 6 13 z raised to 13 is equal to 3 by 2. Is it correct? That is what we are supposed to.
But this is the
सर
addition.
आपल्याला
सर ऍड करायचं
Addition
ना.
आहे मल्टिप्लिकेशन नाही आहे.
ऍडिशन
Sorry. सगळं चुकलं आहे. Okay. More than one mistake. Z square plus 1 upon 2z bracket square plus z raised to 10 plus 1 upon 2z raised to 5 bracket square plus z raised to 14 plus 1 upon 2z raised to 7 bracket square. This is what is to be proved. So then can we simplify this and figure out what is to be proved as a polynomial by making maybe RHS equal to 0. No, I mean let us first check. This 2 is going to get cancelled, so we need not have to worry about 2. Numerator here is going to be z raised to 4 plus twice z square plus 1. This is what is the numerator or denominator of this. Denominator of this is going to
2z square
4z square plus z raised to 20 plus 2z raised to 10 plus 1 upon 4 z raised to 10 plus z raised to 28 plus 2z raised to 14 plus 1 upon 4 z raised to 14 is equal to 3 by. Okay. So how do we go about it now? Suppose we make 4 z raised to 14 as a denominator. Then we are multiplying by 7 z raised to, no, what are we doing? Z raised to 12 in the denominator, less here, so z raised to 12, that becomes z raised to 16 plus 2 z raised to 14 plus z raised to 12 plus here we are multiplying by z raised to 4 plus z raised to 24 plus 2z raised to 14 plus z raised to 4 plus z raised to 28 plus 2z raised to 14 plus 1 is equal to 3 by 2. Is it correct? This implies, with little further simplification, this is gone. So this is 6 z raised to 14 in RHS, and let us write them in descending order. Z raised to 28 is the largest power. Then we have z raised to 16 or 24, sorry,
24.
plus z raised to 24 plus z raised to 16 plus what happens to z raised to 14? 2 plus 2 plus 2 minus 6 gone, plus z raised to 12 plus z raised to 4 plus 1 is equal to 0. This is to be proved. That is to prove that. Okay, so we are going in reverse direction. That is to prove that. So if we want to prove this, and what we have assumed what?
Sir, z raised to 18 is minus 1.
No, just a moment. This is z raised to 9. This is same, na? No, z raised to 18. Z raised to 18 is equal to
Minus 1.
or z raised to काय येणार आहे उत्तर? चला बघा जरा. Now z raised to, suppose I make it 9, what happens? Z raised to 9 is equal to cos 90 plus I sin 90 is equal to I. Z raised to 9 is equal to I. Z raised to 18 is equal to minus 1. These are the identity that we have because we have assumed z is equal to this. So now we can further reduce this polynomial by using these identities. Z raised to 18, so z raised to 10 minus z raised to 10 and minus z raised to 10, and out of that z raised to 9 is I, so minus I z. Shall we introduce I, or it is going to trouble us? We will not get into imaginary business. Let us do it using 18 only. If we do this 18, then it is minus z raised to 10. How much will this be? Minus z raised to 6 plus z raised to 16 plus z raised to 12 plus z raised to 4 plus 1 is equal to 0. Okay, so now,
Sir, we can use
yes, what we can use?
the cube root of unity concept. Omega squared plus omega plus 1 is equal to 0.
Where
Z to raised to the power of 24 plus Z raised to the power of 12 plus 1 is equal to omega squared plus omega plus 1, which is equal to 0.
this plus this plus this.
Is equal to 0.
Yes.
And we can multiply Z raised to the power of 4 with omega squared to get Z raised to the power of 28. And then with omega to get Z raised to the power of 16. And then
Okay,
Z
so
raised to the power of 4 into 1.
what he is trying to point out here is z raised to 4. If we take out common, then we have z raised to 24 plus z raised to 12 plus 1. This plus this and this. Okay, yeah, I mean this is good. So these are the three terms plus z raised to 24 plus z raised to 12 plus 1. These are total 6 terms. Yes or no? Yes. So this is getting factorized. Instead of getting confused here, we can get it factorized here. Z raised to 4 plus 1 into z raised to 24 plus z square 12 plus 1 is equal to 0, and this is equivalent to omega plus 1 plus omega square. Is that right what you are saying, Mr. Shaurya?
Yes.
36 roots. Z raised to 36 minus 1 is equal to 0. So z raised to 12 minus 1 is the first factor, and second factor is this. Z raised to 24 plus z raised to 12 plus 1 is equal to 0. If this is not 0, then this is 0, and this is what is your omega and omega square. Therefore, this is equal to 0. Then we are doing this. That is to prove that, that is to prove that, and yes, we have proved. Okay. I have a couple of more examples like this, which we will do in the next. Bola.